where we are, maybe a little bit where we're going to, and I'm going to turn it over to Sean Rummel. Trout Unlimited, he's going to talk about their conservation portfolio, which uses range-wide data and a bunch of other metrics. And then Jason Coombs is going to walk you all through the modernized version of the occupancy database for catchments and patches. But we're just going to go a little bit down memory lane to get everyone sort of up to speed with where we are. So I'm going to talk about history and future steps of the Brook Trout occupancy database. And can you go to the next slide, please? Okay. You heard a little bit about this earlier. You know, the first major effort of the Eastern Brook Trout joint venture was to put together the status assessment at the sub-watershed level, and that was completed in 2006. Those are 12-digit HUCs. As I mentioned before, a lot of the map was pink, which was the present qualitative data. Next slide, please. And so we modeled in what we thought would be there for brook trout occupancy based on a bunch of other characteristics. You heard about that again earlier, with percent forest cover being the most important factor. And that helped us sort of fill in the map. That was using a cart classification tree system. Next slide. And right around the same time, Trout Unlimited was developing their Conservation Success Index, which at the time was sub-watershed based, and you'll hear more about that from Sean. But that incorporated the brook trout occupancy data, other metrics that had to do with land use, climate vulnerability, land use vulnerability, and kicked out a number of maps. And this one was CSI score by sub-watershed, where blue being very high, so brook trout doing well, habitats doing well, and they're very resistant to change, and red being vulnerable and vulnerable to change. And TU has done this CSI score for a host of salmonids across the whole country. This was the effort in the east with brook trout. Next slide. And then, as the catchment layer became available with NHD+, the joint venture moved to that final resolution with catchment and building connected catchments into patches or occupied brook trout habitat. And what you see here is the 2016 range-wide catchment assessment showing wild brook trout patches, Allopatrick brook trout only in blue, and Sympatrick with brown rainbows, as you know, in orange. So next slide. And it's worth, zooming in. Here's New Jersey, just to show you the difference, in the resolution. So this was a big step forward for the joint venture in terms of where we know brook trout are occupying stream habitat, sub-watershed based on the left, catchment based on the right. And you can see the colors. Blue is brook trout only, and then the other colors are brook trout with other trout. So again, this is more sort of the management size, the catchment size. It makes better sense in terms of what we can do as managers and other stakeholders to make a difference for habitat and population, the catchment size. Next slide, please. So just showing a few of our states here for what we have in the 2015-2016 data. Here's Connecticut. And one of the interesting things is that we haven't really been able to update the data set for brook trout occupancy at the catchment and patch level since that time, since 2015-2016. And that's one of the reasons this has been a priority for our science committee. It's why it's so great that Jason is able to be here today, because one of the goals for the joint venture now is to repopulate with better data and data from 2015 to present. And that's what you're going to learn a little bit more about today. Next slide. And here I wanted to show here's North Georgia, the southern extent of the brook trout range with South Carolina there. And, you know, again, the maps just tell the story that, you know, the populations in the southeast are very small. There's a lot more occupation there than there have been in places like Maine and New Hampshire. And, you know, again, it's this trifecta of forces at work most likely. Habitat loss, legacy and current habitat loss, climate change, changes in temperature and water regime, and non-native species. Next slide. Okay, so just zooming in, many of you know how this works, but I wanted to just walk people through how the catchment scale assessment works. So catchments, you know, they're quite small. The way it was done was, Mark Cuddy and his crew would get the GIS data, would map it out at the catchment level, and then color code the catchments based on occupancy of brook trout. And so allopatric is brook trout only. And so I'm just going to get up to the point, but you know, here's where we had the red would be like a brook trout data, and pink would be, you know, brown trout or something. And so this would be St. Patrick, brook trout, and brown trout, because there's brown trout in there, and they would assume, as a state, all assume would be brook trout. Whether or not that's correct or not, that's one of the assumptions, and Jason will talk more about that. And you would build, you know, through the NHD flow lines, connected hydrologically with brook trout populations. That's how you would build a patch. So it's pretty simple. It's just presence, absence, and then the direction of the NHD layer. And so now, one of the things we have, of course, is data on all trout across the eastern range. So it's not just brook trout, but it's the other wild trout, or if it's St. Patrick brook trout. Next slide, please. And again, here's a way that you can look at a series of connected catchments to build a patch. So most of you all are familiar with this, but I think it's worth going through. This is how you would build the patch layers from a downstream end brook trout, assuming you go upstream. That's the centroid. Where data are available to segregate or separate the catchments, we would use that, like dams. But obviously we don't have the information about culverts, which could be a barrier, or even waterfalls that might be a natural barrier. And so, you know, that's one of the challenges at the scale we're working in the data sets is where those catchments, where those patches are truly connected or not. And Jason will talk more about that, I'm sure. And then patches are assumed to be genetically isolated populations. So these are, you know, a patch is another word for a metapopulation. The terminology that we're using. Next slide. So, you know, to bring this back to how this informs our brook trout strategy, the catchment and patch analysis was incorporated into our 2018 Eastern Brook Trout Joint Venture Action Strategy. And I just put up some of the numbers here. And it might be hard to read, but you know, from this analysis, we're able to sum up all of the allopatric patches. So we know that there's 41,000 catchments with brook trout, and we know that there's over 6,000 patches, or 6,000 metapopulations of brook trout from the data that we have. And this information is available for all the states, which some of you have seen in the presentations before, and the number and size of patches have been used in things like the Chesapeake Bay Basin brook trout strategy. We've used those numbers to develop our strategy. We'll probably use those numbers again after we repopulate the data set and we come up with our more recent catchment and patch data. So that's just some background to get everyone back on the same page. I think that's the last slide. Yep, and I'll turn it over to Sean Rummel with Trout Unlimited. He's going to talk through the conservation portfolio approach to brook trout. Thanks.